So the shipping crates shown are similar. Find the ratio of their volumes. If they're similar, then we're talking about proportions. And just think of this as mapping. 7 goes to 4. Well, the way to get from 7 to 4 proportionally is to multiply by 4/7. So we have this side would also be 4 centimeters. And the length here would be 9 times 4/7 or 36/7. And how do we find the ratio of their volumes? Well, we could just find each volume. So we have 7 times 9. That's the volume of this one. So V1 is that. And V2 is equal to 4 times 4 times 36/7. And the ratio is just V1 over V2. So that's 7 times 9 over 4 times 36 divided by 7. Now we're going to simplify some stuff as much as possible. Let's multiply top and bottom by 7. Right? Multiplying by 1 doesn't change anything. So that 7 cancels with the 7 here, cancels with this 7. And on the top, the numerator, we're left with 7 cubed times 9. Right? We have 7 times 7 times 7. That's 7 cubed times 9 over 4 times 36. And 36 will cancel these two. 36 and 9 leaves 4. So we're left with 7 cubed over 4 cubed, or 343 over 64. Constance is wrapping a gift to take to a party. She needs a box for the gift. The only box she has measures 6 by 6 by 6. She needs a box with measurements 2 times as large. What's the volume of the box Constance needs? How does that volume compare to the volume of the box she already has? Okay. So it's got to be twice as much. So it's got to be, instead of 6 times 6 times 6, we have to do 12 times 12 times 12. And that's 728 inches cubed. And it's going to be 8 times as large, because if we have 6 times 6 times 6, you can kind of see, to make it 12 times 12 times 12, we have to multiply this by 2 times 2 times 2, right? To get 12 times 12 times 12, what did we really multiply by? If we multiplied by 2 by 2 by 2, it means we multiplied by 8. So it's 8 times that of the box she already has. Number 58. Ooh, I like that. It's right on top. So now we have to get rid of all this. Huh? Dummy. Alright, perfect. We know that OP and NQ are parallel, so we can kind of continue these on like this. The segments, it's not great. But we have, oh great, we have to find the values of x and y. So here's x and here's y. Let's find x first. We have 2 triangles here. We have this triangle, NMO, and that's similar to this triangle, OMP. And now so we can just set up proportions. So let's find x first. we can say that 20 is to 10 as 14 is to x, right? 20 is to 10. Oops, I'm sorry, let's go to number 20, okay, this side is to 10. Oh, that's not right. Hold on. And set these up right. 20 is to 30, right? Because let me do 20 in green so it makes sense. 20, which is the green triangle, is to 30, the length of this side. The cyan is equal to 14, as 14 is to, again, we're on the cyan one, 14 is to 14 plus x. And now we need to solve this for x. So let's do some canceling. Let's cancel. Divide both of these by 2. We get 7 and 10. We have 10 over 30, which is 1/3. We can multiply both sides by, well, this is cross multiplication, but that's not a great habit to be in. Well, we're 10th graders, so 3 times 7 is 21, and that equals 14 plus x times 1, so that's 14 plus x. So x has got to equal 7. So we have x equals 7. That's the only one right there. But let's get y also. We know that 20 is to 30 as 19 is to y. So let's do that. 20 is to 30, just like this proportion, is as 19, the green triangle, as is 19 is to y. So, okay, cross those out. 2 is to 3 is 19 is to y. Multiply both sides by 3/2, and multiply both sides by y. And you can see these cancel. So y is equal to 19 times 3 divided by 2. 19 divided by 2 is 9.5, times 3 is 28.5, which double checks with that right there.